Hello everybody and welcome to this tutorial series about creating a mobile-friendly physics game with Construct 3. Today is session 3 and we are going to create our main mechanic, which is the catapult, the slingshot mechanic. So let's start. First of all, let's finish our setup, and what I'm gonna do is, I think we were working with a 1080p resolution, and we are going to make our layout the same size. So it's oh, sorry, I have to pick again because I can just copy this, and when I go to the layout I can change the size just by pasting that that value. So now we have our main space of work, and we are going now to create a little environment so we have something to work with. And let's start by creating our background. So let's look for background for this. We can create maybe a tiled background, and we just need to have some texture for it. I'm sorry, I'm going to look for the texture. So here we have some assets, and let's see what we have in our Kine physics pack. So let's do PNG, and let's use, for example, it has to be something here, backgrounds. Okay, cool, maybe this one, or maybe just okay, let's see, for now just this one. That's our texture. Let's see how it looks in the game. We can see that we are missing kind of a space there. So what I'm gonna do for now is, and I want you guys to remember that a tile background, it's going to repeat itself endlessly. So that's the advantage to use an image, or a modular image for a background, because you only have to have that texture and it's going to repeat itself, so you won't be like occupying space for a bigger texture like this size. So to fix this kind of little having space repeating itself, because the image is looping vertical and horizontally, and we're going to change that. Let's first of all check how much we need. The texture is actually something like 10 and 21, and we need it to be like 11 and 10, maybe something like that. So we can come here and we can increase the size of the height. We just say like 11 and 20, and here we are going to say, hey, align to top left. So the image is gonna get some space down here. Now I can pick this color and use it to fill the rest of the image. So now we have a complete image, and it's not repeating itself. It's just enough for what we need. We have our background, and we can then rename our layer so we know that is our background. Okay, and that's going to be our layer. So we have that now. It's a background. Let's create another layer, another new layer here, and this will be our physics objects. Let's just call it objects for now. And make sure, guys, that you have that new layer selected, because every new object that you insert into your project will be put inside the layer you have selected here. So then you will be avoiding to need to change the layer of every object all the time. So now we maybe need some kind of floor for this. So let's check what we can have here. Maybe another tile background could be useful, or maybe just, yeah, let's go for another tile background. Let's see what we can find. So new object, tile background, and let's look for something useful. Maybe here. Yeah, we have kind of grass here. That will be really useful. And now we can just adjust the size. Remember that you can use the grid just to make it easier to manipulate all the objects. Let's see, just leave it here like that for now. Just like that. Okay, we have now our environment for the game. If we hit play, we will have this preview of our game, which will be good for now, as I said. So now we need basic, and I'm going to create another layer here for physics. So let's create a layer on top, and this will be, I'm going to call this surface, and this maybe here it's better here. Okay, surface. And now I'm just going to create like a sensor. It doesn't need a texture. So I'm going to use a sprite. I'm going to create here some color just to give me the idea that that is the sensor. Any color will do. I'm going to give speed 0 for animation speed, and we have it. So now I'm going to make this on top just to be able to see it. You also have this element here, this property, which is opacity, that you can use for your sensors, so you can see your sensors but they won't be in the middle. I'm going to change the origin point to 7 here. Okay, it's okay, so they don't get in the way and you can easily see what you have behind. So let me make this larger. And since we are going to work with physics, our first behavior shall be add physics. Remember that you can filter here your search physics. There we go. And now I'm going to rename this object to be surface. Okay, and that surface will be just here down. That will be our floor. but we can also use it, like duplicate it and use it to limit our level in every direction. Oh, I'm sorry, I have to press Ctrl and drag this. That's okay, and we can like make this our limiter. Okay. So now we have our first physics object, but remember we have gravity, and if we hit play, everything's going to fall. So since this is just scenery, we will make that immovable. We need to check this box. So now you can see that when I hit, it will stay in place. The next thing I want to do for this is just to make it invisible. So it exists, but it won't appear when the game is being played. So that's it. We have our environment, our level context set up, and we can go for our first object. So what we have to do now is to create our first physics object, which is not scenery, and that might be our projectile. Okay, so let me first, it's always a good practice to arrange this, so I'm going to create a system folder so I can put there the mouse and the touch object. That's okay. And now we have here, okay, maybe another folder will be cool for our scenery, and we can put these guys here. That's great. And for now, let's use this out of any folder. And okay. So let's bring in our first guy. Let's insert a new object. This will be a sprite object. And let's search for something useful here. So, for example, first thing I want is my projectile for the game. So we are going to look in the, I believe it's Animal Pack Redux folder. This is also from Kini. And now let's look for round outlined objects. So we were working before with some of these, and you can pick wherever you like. I kind of like the, let me check. Let's use the parrot to start. And we have our parrot, and we can say just the set to bounding box, because we are going to use not this bounding box for physics, but a round shape. So first things first, let's establish some sort of basic size for our game. So I'm going to make the grid visible, and grid is 22 by 22. Maybe this is too big. I want something like 64 by 64. Oh, but here's the thing: when you make die resizing, you need to be careful. You can keep the aspect ratio, so you can maintain the proportions of the image, and also you need to make stretch, because otherwise it's gonna cut off the edges of your texture. So now I'm gonna put here like 64 something, and let's see how it looks. That's more like it, and this will be my my projectile. Looking good. Okay. And now we need to give this object the behavior of physics. And that will be our first projectile. So let's call it I'm gonna call it bullet parrot just to keep order on my objects. So any object which is a projectile, I'm gonna call it bullet, and maybe after that a suffix or something to make it distinctive from other objects. So this is our first character, but I don't actually. I'm gonna take away the physics behavior from it, and I'm gonna tell you why. Because maybe, or of course, this is not going to be our only physics object, so it's a good idea to create a family for all the projectiles. So I'm going to create a family. I'm going to put this guy in here, and this family will be called famlets. So in that way, I just need to add the behavior of physics to this to this family, and it will give the behavior of physics to any object inside that family. As you can see here, here's our bullet parrot, and we can have like a very basic, and let's just work with what we have here for default for now. That is the very basic behavior of physics. We have gravity affecting this. Now I want to create now like some structure to make the role of the slingshot, of something very basic. But let's do it. So let's go for another sprite, and maybe here, or let's use another method. And I'm going to just go to our files, go physics pack, png, and maybe some wood element will serve very well that purpose. So for example, just for example, I think I can use this. And now we have that object, but I want another frame. Okay, so I'm going to select this and go for another frame, and let me check. Oh, I need to go back a little bit here, and inside wood elements I would like to use something like this, or maybe like this. That's okay. So we have two frames. I'm gonna use this animation speed, make it 0. It doesn't matter the bounding box of this. Yeah, okay. So now another thing that I'm going to do is to change the origin points. And now I'm thinking I need this to be smaller. So maybe just I'm going to choose a different width, and that could be something like, I don't know, 48. Let me check. Yeah, that's better. And for the triangle, maybe something like here in the width 64. Okay, and now I can just clone this, not clone, duplicate this instance, and I'm going to change the initial frame to 1. I already know that is the triangle, and I made a mistake. So maybe we can just give back the size of this. Otherwise we're going to have to, yeah, now I'm going to replace it and check first if it looks good or not. So let's see. No, initial frame number 1. That's better. That's much more like it. And finally, to finish my slingshot element, I would like to create some like circular form here. So, but for this it's going to be a reference object. We are going to be using its position. So we need to make it more independent, and we're going to call this then. This is not element wood. I want you guys to notice that when you insert a sprite, just like dragging and dropping from your folder to construct, it will create the element and it will give it the name of that element of that image. So if the element of the first image I dropped here was element wood, and what's important here is that if you use a good system for naming your objects, you will save time because you won't have to rename them here when you drag and drop them into construct. So it is a good practice to name all your assets with a system, with an order system, so you can use it and you can save time here. So I'm going to call this like catapult base. Just to make the shorter name, catapult base. Okay, that's okay. What is this? This is a new object. So we are going to bring here something like, I don't know, something like this. Let's see, make it 0, and I would like this to be on top of the other two. That's cool. Triangle, just to make it more. I'm gonna reduce its size, maybe just a little bit. Oh, what happened there? That's okay. Yeah, it's working okay for me. I don't want our guy to be that small, so I'm going to re-import it. Animals, don't forget animals pack. Round outline. So let's bring this guy here again. Let's maybe not that small, 64. Let's try something like 100, and we need this animation to be 0 here. Yeah, that's more like it. That's better. It's a good size. Okay, now we have all the basic stuff that we need. We have all our game objects for this lesson now. So the next step here is to start thinking how this shall function. So the first thing is that we are going to need our guy to stay in position when we start our game. So we need this guy to be always like in the center of the slingshot and kind of be pulled towards that center. So we are renaming this object. It'll be like cut up center. I'm gonna call it like that. And the first thing we need to do here is we're going to add let me add a global variable. So in this game there will be basically two important moments during the gameplay, which are when you are aiming and when you are not aiming, when you release the shot. So let's create a global variable called aiming. And it will be a Boolean variable. And its initial value will be, since we are going to be aiming from the very beginning, just leave it like true. Remember, these variables are like switches, the Boolean variables, so they are either activated or deactivated. So when it's aiming, we want our bullet, our projectile, to be positioned in the center of our catapult. So the first thing we need to do is to create an event and test if we are or not aiming. So that will be compare is Boolean set. So we are going to compare if this is true. So we choose that, and it's already our condition. It says if we are aiming, and the first thing we need to do is our blue parrot in this case. And let's start simple. This is gonna get complicated if we have more than one bullet, but for now let's just use that. And okay, so we need our bullet to be in a position, like always in a position. So we're going to set its position. So you can look here, angle, animations, appearance. There's the physics and size and position. You can set this position of the position of this object to another object. So we are going to choose another object, and we are going to choose catapult center. So every frame it will be positioning our bullet to the position, to the origin point of this object. So let's see how that works. And now we have it. It's like despite we have gravity, it's like fixed there, because every frame the game is telling, hey, you should try to be here. So we have a gravity action working, but it's countered by the order that we just gave to in our game logic. So next step, if we are aiming, we need to be able like to pull our bird far from apart from the catapult center. But when we do that, since it is supposedly attached with a rubber band, it should be always like looking at the center of the catapult. So we are going to do two different things: set the angle of the bird, of the bullet, and the other thing is like move that bullet while we are dragging our mouse. So we have here our first position, but we need to add a sub event, because remember, we are going to be either dragging or not dragging, so we need to tell the game what happened in both situations when our boolean aiming is true. So let's add a sub event, and our condition should be something like related to the mouse for now. But since we are making a mobile friendly game, I want to talk about one special thing here. And we have a problem. Do we have, let me check one thing first. Yeah, we have the touch object. So in this sub event here, there we go. We have these two different system objects, and I want you guys to be aware of one thing. If you want to create a mobile friendly game, but which also works on a desktop PC, for example, for web, where the user has a mouse and a keyboard, you might need to create a different input system for each one. But in regard of like tapping and dragging and that, you can use just the touch, because these acts, let me use that one, and I will explain you what are we going to do. So the first thing is that that will be compare if it's in touch. That means that imagine your player if it's touching anywhere on the screen. That is the condition. But let's add another one just to show you guys about the mouse. And cursor is over object, on click, mouse button is down. So imagine this left button, and what we are going to do here is that we thinking on a desktop game, we shall use the mouse action, and thinking about a mobile game, we shall use the touch action. Okay, but construct has an option here, and if you go to the touch, you can see selecting here the touch object, you can see here this option which says use mouse input. And what that does is that whenever you are in a touch device or over the web using a mouse and a keyboard, construct will tell the game that even if the action is based on touch object, it will make it pass as if it is a mouse. So for example, making a tap will be the same as making click, as doing click. For example, doing touch and keep touching your screen, it will be the same as letting the left button down. So you can kind of use this. The only thing that you can't do, of course, is that you only have one cursor for the mouse on a desktop PC, for example. So with the touch object for mobile games, you can use multi-touch, but you cannot expect that you make a multi-touch action in construct and work the same way just in a web version for a desktop computer, because you don't have multi-tab or multi-cursors for mouse. So that's the limitation there. But for now, we are going to make both of them so you can compare how that works. So the first thing we need to do is to move our object, and we need to move our object certain distance, depending on what do we do with our finger or with our mouse. So we need to move the object based on that distance. So what we are going to do is use a special action for our part. So whenever we are touching, we are going to let me search here, move at angle. So what this is going to do is it's going to move the object certain amount of pixels at a given angle, and that angle is wherever we want to define. So we're going to use that, and we are going to start using expressions, and that is the most the thing most like coding that you are going to be doing in construct. So this is basically using keywords that are going to make something for you, to allow you to program certain things and to make reference to certain things. So let's make this really slowly so you can understand. We need to say towards what angle are we going to move the object. So since what we are talking here, and I'm going to just leave this for like that for now to be able to show you guys here. The bird, it's going to be just in the center, right? I'm going to log this. Okay, the bird is going to be just in the center. And just for now, let me put it up here so it's easier to select. Oh, I'm sorry. Okay, what am I doing? Okay, alright, something's really strange here. It's kind of not working. Okay, not working properly. So what we want to happen is that when we move our mouse, this bird kind of follows our mouse, but as if it is attached with a rubber band to the center of the catapult. So for that we need to say or to tell the game that when I drag my mouse, it needs to move this bird towards that position, but not exactly that position, but because we need to limit that position, because we could be like moving our mouse here or here, and you don't want to move your projectile just to wherever, to like something infinite. You need to limit that movement so you can go further than, I don't know, than this. Let's just make this like that so we have a little more space, and let's put some limit to that. So for example, I'm going to move this to the top of the layer. Let's say this is our maximum amount of pixels that we are going to move our bird. So if we have this position, which is 832 in y-axis, and then we move to, let's say, this position, which will be 9 and 60, we will have a difference of about 164, 148, if I'm not wrong. That's the maximum distance that we are going to move our object. This is 64 and this is 128, right? So we're going to go back here and let's say how much distance towards that angle, and let's say for example 148, I'm afraid, and which angle we need to move that object. So we can use an expression called self, which will refer at that object, since we are making an action for the bird, the parrot bullet. Self means parrot bullet, and we can here choose from the list the word angle, which means that we will be moving our parrot towards that angle. But let's see how that works so far. So now when I drag, it's moving the parrot, but it's just positioning there just at a given distance towards the angle of that parrot, which is this is angle 0. Since it's not rotating, it'll be like if I'm telling okay, just move forward that amount of pixels. So we need to rotate our parrot towards the catapult. So we are going to add another action, and we are going to say, hey, we need you to set an angle, but we need to know what angle is between the parrot and our catapult center. So we can do that with another expression. So what we're going to do is type in here angle, and we're going to put a dot. No, I'm sorry, angle. The angle expression will allow you to find an angle between two object positions or two points on your layout. So we need to find the angle between our parrot and the center of the catapult. So what we're going to do is to make self.x, which is the current x point or x position of the parrot bullet, colon, and then against self self.y, and then colon again, and we are going to enter here the other object's position, which will be the catapult center dot x and the catapult center dot y, and we need to close the parentheses to make this work, and we're going to hit done, and let's see what happens when we do that. It happens something crazy. Let me check our logic. We need to set the angle. Set x, y, catapult center x, catapult center y. That's okay. But we need to do another thing. We need to make that distance not something fixed, but something like more like a rubber band. So we are going to change our... Oh, there's a problem here. The first problem is that I'm doing this after I'm setting the angle after we move the object in every frame, but really we need first to set the angle and then move the object. So maybe it doesn't look that crazy now. Yeah, it doesn't. Okay, let's fix here the movement of our parrot. So this is not that simple. We need to make it dynamic. So the first thing we're going to do is that we need to limit this distance, because it won't be a fixed distance. So we need to make a choice between two values, and let's use expression called min, and min refers to minimum, and for that expression to work you need a parenthesis there. So you need to set here a distinction between two values. So which value it's you are going to compare two values for moving the object. So what is less, the distance between my mouse and the center of the catapult, or the distance between my maximum limit, which we say it's going to be like 148, and so then the game can choose which distance is minimum and set that distance. So let's make that, and we need to input those different values. So the first thing is the distance between my mouse or my touch and the catapult block. So we are going to include here another expression called distance, which will allow me to determine or will return that specific distance. So we need the position of the two objects. So we are going to use touch to refer to the place where I am doing the touch. So touch X and touch Y. And the other object will be the catapult center. So the same catapult center X and catapult center Y. So I have now my two values, but I need, that is the first value, the distance between those, or the other distance, which will be, for example, 148, and we are closing those parentheses too. Let's see if this is working as I intended. So yeah, I am limiting this, and you can see now that I can't go any further from here. I can't go any further, and that looks more like a slingshot because, or a catapult, because it's going back towards the center whenever I release. Okay, so we are halfway through, bear with me. The other thing that I may be doing wrong is that I'm not correctly setting the angle. So here I need to find the angle not between these two, because I'm not calculating a distance, but I need to set the angle which is from where I'm making touch or click to the center of the catapult. So this self shall not be here, this shall be touch. The same goes for this position. Let's change that. Okay. And in that way, it should work. Let's see what happens. So you can notice here that this works more like a slingshot. The further I go from the catapult, the farther the bullet parrot goes, but it's going in the opposite direction. And as you all know, that's basic mathematics. The only thing I need to do is to tell this, please add 180 degrees to that. So it's going to follow my position. And if I go to the right, it goes to the right, but at the moment that I reach the limit that I established, which was like 148 pixels, it's going to stop and take that value. Instead, the distance between my mouse or my touch and the center of the catapult. So we can kind of have here what we need. The next step will be to maybe to set the angle of the parrot itself. I'm sorry, we already do that. The next step that we are going to do here is to make that like that displacement of the slingshot a little more soft. So what we can do here, instead of just saying that this total distance, we can divide that value. So this is the total distance between my touch and the center of the catapult. But maybe if we divide this by some value, let's say 2 or 3, it'll be smoother and it will feel more like a slingshot, and also it will feel easier for the player to control the distance because it will be more exact. So let me show you what I'm talking about. We are going to here like divide this distance, this total distance, by 3, and you will see how when I pull the mouse, it's not going towards the exact position of my mouse now, but it's more like somewhere in the middle. I'm somewhere exactly the third part of where I have my mouse. So it feels more precise. You can do a larger, like you can make more distance with your mouse, and the parrot will be moved less distance, so you can be more precise. And that's the thing that I like about dividing that amount of that distance of the mouse. You can see here, guys, how that works. We could do this a little less, for example, like 2 or 2.5, you choose, and look at that. That works cool too. And it's going back to the center. So the final thing that we need to do here is to tell what happens when we release, when we are not aiming. So what's going to happen is that the part should like be fired and shall be thrown as a projectile. So let's copy this and just let's invert this condition. So what happens if I am not aiming anymore? But the other thing here is that will happen when I am not in touch, which means that when I release the parrot. So for now, we can sort of use the same condition. Let me copy this condition, and we are going just to change it here, and we are going to use on any touch end, which means when I release. And that what's going to do is that it's going to trigger something when this variable is aiming and is true, and when I release the touch. So what we need to happen here, and that's why we were learning, that's what we learned the past lesson, and it was using impulses to fire our parrot. So we need to apply some physics to this guy, and we need to apply that impulse towards an angle, I believe. So what impulse? And it'll be cool that, or the idea here in this link shot mechanic is that depending of the distance between the projectile and the center of the catapult, you will have more or less force to move the object. You will have more or less impulse. So let's make it like that, and we are applying the value for the impulse will be the distance between and since we are talking about the touch, we can do just since we are talking about the catapult. No, I'm sorry, guys. Since we're talking about the parrot here, we can use now the self x and self y expression. And now the distance between the current position of the parrot, we need to compare it against the block, the center of the catapult. So here we go, catapult.x and catapult center.y, and that is the distance between I'm missing a point here. Okay, and that is the distance at that moment between the parrot and the center of the catapult. Now the angle, at what angle we need to shoot. So the angle at that moment shall be the one for the parrot. So let's use self.angle, so it goes in the direction of the angle it's aiming. And image point, it's okay to leave it 0. So let's and the next thing, we need to set aiming to false, because Otherwise, it's going to pull our parrot again back to the center of the catapult. So we need to set that boolean aiming to false, and we need to do that before applying the impulse. Okay, and after that we can try how this works, and we can see, and there's something here that is not working right. Let's do it again and see what happened. And is that our parrot is changing, has an inverse orientation, so we need to fix that. But we are almost there. You see how it works like a slingshot. So let's see how we can fix that. So set angle. We need to set the angle of the parrot. Let's see what happens if I don't add this 180 degrees. Maybe that's the mistake. Let's see what happens. If I pull the parrot, it goes in the opposite direction. So the problem is here that maybe we need to fix the angle of moving the parrot, not the angle of the parrot itself. So here we can not to self angle but self angle plus 180. See if that works, and that works much more better. You can see now that is facing the right angle every time, and when I release we have our projectile. Maybe it's too much force that we are applying when too much impulse that we are applying when we release, so we should like limit that or somehow making it less strong. So what we can do here is start dividing this. For example, it could be 2. Maybe let's check how that works. It will be half of the strength. That works much better. And let's see, for example, maybe 3 works even better. Something like 3 or 4, 3.5. Let's see, because we need like, okay, that it's maybe a little more better. Still not much. Maybe we can increase the distance to have a little more strength at the end. For example, our limit here shouldn't be 148 but I don't know, 160 maybe, and maybe not 3 but 3 point just 3. Let's see how that behaves. Kind of works nice. It's something more like Angry Birds, you know, the movement now. Maybe we can work with our parrot with some of his properties, like maybe it's too dense. Let's make it not that dense, and maybe a little more bouncy, just a little bit, and let's see what happens here. That's something more interesting, a more interesting movement. And okay, so that, guys, is how we have now our first and main mechanic, the slingshot mechanic. So what we did here, to make a resume, is that we can move our bird away from the center of the catapult, and depending on the distance, uh, we have a different impulse when we release the bird. And we also, to be able to achieve that, we needed to make our bird always be facing the center of the catapult. And we need also, other thing we did was to make like a limit for our parrot, so it can go further than we desire. And we also use a technique to make the aiming experience like smoother. So that's how you create the slingshot mechanic. I hope you guys had fun. I'm sorry if sometimes it was a little confusing, but after all, I think it's pretty clear now what we have done to achieve this mechanic. So I hope to see you guys in the next lesson, and we are going to create the other objects, the objects that we are going to hit with our parrot. So stay here. I hope to see you guys in the next lesson, and let's go.